Open your book to page 235. So today's lesson is on sum identities, difference identities, and cofunction identities. So first, let's look at the sum identity. So the things that make it difficult is that the trigonometric function is not a linear function. For example, if you have x equal to, let's say x equal to 30, right? Then 2x will equal to 60, right? You just double that, right? But because trigonometric function is not linear, you can just double that. For example, if you have sine of 30 degrees, well, what does that equal to? Well, if you do this, right? So that's 1, 2, square root of 3, right? So sine of 30 degrees is 1/2, right? Now, what is the sine of 60 degrees? Does it double? No, right? You don't just say, oh, this is 1/2, so you double it equal to 1. No, it doesn't work that way. Because sine function is not linear. It's circular. So if you draw your trig function, draw your triangle, you can see that 60 degrees is square root of 3 over 2. So you don't double exactly, right? Again, it's not a linear function, so you cannot just double it. It doesn't work that way, okay? And so because of that, they in a book they kind of derive how they get the sum and the difference identity. So we're not going to try to prove that. We're just going to use it, okay? So if you look on your handout, the sum identity. So here are sum identity for sine, cosine, tangent, and difference identity for sine, cosine, tangent. So, okay, so, and the way to memorize this is, I kind of don't like to use x and the y because students have tendency of getting confused. I kind of like to use a and a b, okay? So let's say if you have sine of angle A plus angle B, so this will equal to sine A cosine B. And for sine, if it's plus, you're going to get plus. So for sine function, you switch you can switch the letter. So sine A cosine B, and then after that you get sine B cosine A. Okay? So that is a sine function. Then when you have the difference, the sign would be just opposite, right? So A minus B will equal to sine A cosine B minus sine B cosine A. So the way to remember is that for the sine function is sine cosine, right? Again, sine cosine. And if it's plus, you get plus, minus, you get minus. Okay? And then you got an AB, BA, AB, BA. So try to remember based on pattern. Okay? So that way if you remember one of them, then you can able to remember rest of them. Now for cosine, okay, for cosine, and you can notice if you sine, you start with sine. If it's cosine, you start with cosine, right? So for cosine, it's going to be a little bit different now. For cosine, it's going to be cosine A, cosine B, and this is going to be opposite, and you're going to get sine A, sine B. And for cosine of A minus B, you're going to get, again, you're going to get cosine A, cosine B, and plus sine A, sine B. Okay? And so again, that's how you memorize the function. Okay? Again, go by pattern. For sine function, you get sine, cosine, sine, cosine. You start with sine, right? And plus or minus you match, and you're going to get A, B, and you switch. So over here you switch the A and the B. Okay? And over here cosine. Again, if it's cosine function, you start with cosine. And so for the cosine function, you get cosine, cosine, then sine, sine, cosine, cosine, sine, sine. Okay? And then this will be opposite. If it's plus, it becomes minus, minus becomes plus. Okay. So again, go on pattern, go by pattern. And the tangent, this one you're going to get. So again, the way to remember is the tangent x plus y. So you're just going to think of that like a distributive property. So you're going to get tangent of x plus tangent of y. And down here, would become 1 minus, so this would be opposite, and then you multiply, so it would be tangent x, tangent y. So again, try to use a pattern to help you to memorize. So tangent of x minus y. So again, you're going to get tangent x minus tangent y, and 1. Now because this is minus, so it becomes plus. Okay, and that's it. Okay, so these are the 6 very important functions that you need to know. Okay. So let's go over some examples. So let's go to page 240, and let's look at example 1. So you have sine of x minus pi, and you want to use the difference identity to simplify that. Okay. Again, first I'm going to write out the formula. Okay. So sine of a minus b is equal to sine a cosine b minus sine b cosine a. Right. So that's my formula. So I'm going to substitute. Right. So again, this is my a, this is my b. Right. So sine a would be sine x, cosine b would be cosine pi, minus, so that's your a, that's your b, right? So minus sine pi cosine a, cosine x. Okay, so you can write down your formula and you just match it up, and then you simplify. Okay, cosine of pi is equal to what? Again, draw your picture. Pi is over here, right? So cosine is negative 1. Okay, minus, and what's the sine of pi? 0, right? Right over here. Sine of pi is 0. And so this becomes negative sine of x. Okay, and that's how you simplify. So you, again, the best way to do it is write down your formula, write down your identity, then you substitute and you work it through. Okay? And it's not that bad. Okay, now let's go to example 3. You're looking for cosine of 15 degrees using in a radical form. So if you try it on your calculator, it's going to give you decimal. So that's not exact answer. So you want to use the radicals. So you want to find a way to use any combination of 45 degrees, 30. So you want to use combination of 30, 45 degrees, and 60 degrees because you know those values, right? You know how to evaluate those. So you can use any combination. So this one, you can make into cosine of like 45 degrees minus 30 degrees, right? Or you can use cosine of like 60 degrees minus 45 degrees, right? So you can use any one of that. Okay? So again, there are more different options, but I think this is the easiest one because it's the lowest number. Okay? So let's go and use these. Okay, so this is equal to that. So again, you want to make the angle into 2 angles that you're familiar with. Okay? So that is your A, that's your B. So again, write down your formula. So cosine of A minus B equal to cosine A cosine B plus sine A sine B. Right? So you get cosine of 45 degrees, cosine of 30 degrees plus sine of 45 degrees, sine of 30 degrees. Okay? So this is equal to square root of 2 over 2. Cosine of 30 is square root of 3 over 2. You got to know your spatial triangle, right? Plus sine of 45 is square root of 2 over 2. Sine of 30 degrees is 1/2. And they should have a common denominator. If you don't have a common denominator, it means you're doing something wrong. So this is equal to square root of 6 over 4 plus square root of 2 over 4. And if you put together, this will equal to square root of 6 plus square root of 2 over 4. And that is your answer. Okay? Okay, let's go to example 4. Okay, example 4, it says find the exact value of cosine of x plus y. So you're looking for cosine of x plus y. Okay, you're giving that the sine of x equal to 3 over 5, and this is in quadrant 2, and then you have cosine of y equal to 4 over 5, and this is in quadrant 1. Okay, so first you need to do is go and expand that. Again, that's your A, that's your B, right? So cosine of A plus B equal to cosine A, cosine B minus sine A, sine B, right? So this is equal to cosine of X, cosine of Y minus sine X, sine Y. So now you have to evaluate. So the way to evaluate is you have to draw your triangle. So it tells you that this is quadrant 2. So it's right over here. And it tells you sine is 3 over 5. So it's 3, 5. So this is negative 4. And make sure you label your angle so that your X over there. And this one you have to draw another triangle, quadrant 1. Okay. So this is your Y. And it's 4 over 5. So this is 3. Okay, so you got to draw two triangles, one for X, one for Y. So now you can go and look at a triangle to evaluate. Cosine of X is this one over here. So it's negative 4 over 5. Cosine of Y, you have to look at this one here. So it's 4 over 5. Okay, so sine of X is this one here. So it'd be 3 over 5. Sine of Y is this one here. So it's 3 over 5. Again, you should have common denominator, okay? So this is equal to negative 16 over 25 minus 9 over 25. And so this is equal to negative 25 over 25 equal to negative 1. And that's your answer. Okay. Okay. Let's go to example 5. Okay, example 5, you need to verify. So you have cotangent y minus cotangent x equal to sine of x minus y over sine x sine y to verify. Okay? So this side is more complicated now because you have the angle is messed up. Okay, so this side is more complicated than this side. So you need to simplify this side. So use your identity. So you're going to get sine x cosine y minus sine y cosine x. Right? Again, use your identity. So you get over sine x sine y. Right? But if you look on this side, you got two terms, you got one term over here, so you need to separate these, right, to match up what's on this side. So go and separate these. So you got sine x cosine y over sine x sine y minus sine y cosine x. All I'm doing is just apply that formula, right? Apply the difference identity. Again, focus on the main concept, okay? And then this one, you can cancel these things out. So you got cosine y over sine y, you get cotangent y. This one, this cancels out. So you got sine y. Oh, wait, I did something. Did I do something bad? Yeah. Okay, sine x, sine y. Yeah, messed up on that. So be careful. So this one get canceled out right over here. So you get cosine x over sine x. So don't cancel this out. Okay? Yeah. Okay. So be careful because there's a lot of things going on. So cosine x over sine x will give you cotangent x. And that's what we have, right? And so put a check mark. Okay? So again, so it's nothing new. You just apply the identity that you learned from here, right? So make sure you're familiar with the sum identity and difference identity. Okay, so let's go and do some practice.